rundown also.
Yeah. All right, guys, let's start. Today we're going to do the hacks between 6 and 10 from the season 1. Number 6, it's basically visualization sliders. Is like really like one add-on, one extra add-on, which is actually pretty cool. But how useful is going to be, like right here, you see that this covers only like the how to create slider for CADcad parameters. And to be honest, the only implementation that it requires is having like the Plotly Express and of course NumPy a little bit for the math involved, and the rest is like the usual stuff. Yeah. Then the rest is the same here. It takes the model of hack number 2, so the, how is it called, man? The predators,
prey
predators.
Predator.
Yeah, exactly. And I think it doesn't change anything until the output preparation. Here in the output preparation, they did again like the long procedure that we saw. I don't know if it was in 4 or 5, something like with the substeps, in order to indicate the substeps a little bit more.
Yeah, it's in order to ignore the substeps that exist, because I think one time step is equivalent to 2 different substeps, and so they just want to get the initial state and the final state within a time step.
Exactly.
That's the reason.
That's the reason this is like this a little bit, but that's the only thing. And then you go to the analysis, and to be honest, I don't know why is it not run? Okay, I can just
the only thing that changes there, we already imported the Plotline Express once. The only difference here is that you add a different, exactly. It's the animation frame that you now can output, and you'll have like a slider where you can pick every single Monte Carlo run.
Yeah, but I want to run. I want to run all. Okay, I want to restart and run all just in case. And let's see how it looks like.
Yeah.
So we're checking out.
So basically, this hack is only about Plotly Express. So you
yeah, this is really not much, and you can see it here. And then like from these runs, you can actually like imagine, you see every individual run. In my opinion, it doesn't make much sense to have like every run like different, because of the runs are like, I would have in this axis like something different, because the runs, they are stochastic, they are statistical. It's not very relevant to see the difference between them individually, you know? So this is going to be very useful when you have like, I don't know, like dates, when you have like something in the x-axis that actually is relevant for your discussion, because here you would not gain much information just by checking them individually. You probably will want them to see them all together to see more or less the average of all of them, all of the runs, you know?
Yeah, to see the trend or something.
For example, here is way more relevant, because instead of like using the runs, it uses the parameter sweep. You know, it checks the prey birth parameter from 0.6 to 0.1, and you can see how by incrementing the prey birth parameter, you get a way more dense, like a way higher frequency plot. You know, in terms of way more seasons of prey population.
Yeah.
So that's the only thing.
Yeah. So, I think the play button is really useless, I think.
Yeah, quite useless.
Because it's like it just makes me so confused. Like I don't even know the usefulness of that. Like what the fuck is going on? Like what am I gonna do with that?
Oh man, maybe you prepare a presentation with that. You know, you want to see like how, because here you only have 5, but maybe imagine you have like 100, and it's like a time lapse. You know, a little bit of like how it develops over time, certain things. You know, but here it's useless.
Unless you want to confuse your VCs, then you're on the good track.
Yeah. And it goes super quick, you know. The runs just like bam.
Yeah, it's a nice way to flex your like Plotly Express knowledge.
Yeah. And it's only going to be relevant in very specification. And I think the only thing that they added is like this one specifically. I don't see any other add-on. Otherwise, you just need to check the hack, and it would be fine. All right, then we go to number 7. Number 7 is to get like live information, so live database. In this case, they use like CoinGecko. This is actually pretty useful, because this is in order to get data from real time that like updates it the whole time. Every time you run it, it's updated. So that is actually pretty useful. I don't know if it's gonna work. Actually, I haven't tried it out because I don't know if this address is gonna be like right or not. Actually, I can check it out. And for what because from what I've understood, here you get JSON because I think the data that you get it's on JavaScript. So you need to kind of like make a transformation so that like Python can go over it.
Yep. So basically, when you get the data from the API, it's usually gonna be in JSON format, and you need to
So here they defined like this is the process in which they get the database. Like they try to get over time they want to analyze what's the relationship between ETH BTC. So basically like how price wise how much is ETH compared to BTC, and they do it by applying for this API. Like it's here, and then I think everything here is basically standard. You create a dictionary because at the end you need to have like this data as in the dictionary, and at the end like you even like need to make a like from the list that you get, right?
Yeah, basically it creates another dictionary with just I guess one column. I mean using the column from with the prices tag. Stuff like that. If I understood it correctly.
Okay, I think like there's not much more than this. Like I said, if you want to stop me anything with the code, because I'm not a like great expert with code at all, so I normally whenever I don't understand anything or something, I just like assume that it's copy and paste. I don't fully understand.
It seems like that this is just like data preparation standard procedure. I mean, no insights for us.
Okay.
Actually.
It's cleaning the data basically. It's cleaning the data so you can manipulate the way you want it.
Yeah.
And could you just pull up a little bit, please?
Yeah.
Scroll up. Let me see. That is just basically Panda functions that are within the data frames interface, basically.
Yeah.
The sign query functions. So don't get scared. If you're really unaware of what this function may do, I advise you to consult the pandas package and pandas library so you can have a better knowledge and maybe get used to it, because it's going to be needed in token engineering for sure.
But what do you mean exactly? Like this part, or like what specifically? Like
I was talking because I was just going to say that when you are going to apply knowledge in token engineering regarding to data, you're going to need two main libraries, NumPy and pandas.
Yeah.
And these two libraries are going to be crucial, 100%. So if you have doubts, you're going to have to investigate. That's just my outputs.
Okay.
Say.
Yeah. No, I'm trying to learn to. I do understand what the Panda library does. It's just like in terms of execution, I get a little bit confused why they do it in this way and not in other ways and things like that. Like I'm not there with that knowledge, but that is something that is not a big problem for now.
I think it comes with experience.
No rush.
Yeah, 100%.
So they're getting the information from this year's, I guess, like from 2020 until 2021. And here it becomes a little bit interesting. Here, apparently, in Python, like in order to start, like I don't know why here they say none and here they start with 0.0. So I guess this is
because they are going to.
And this is
I'm sorry, because they are going to be updating it. No, that's not a string. That's going to be a time step. The time step they created above, and they are requesting from the API. For example, that's going to be for like 1st of January 2021, and it's going to be changing all along. It's going to be a data stream in the future.
Yeah. But like, why here would it be?
But like, I remembered.
And here is 0 because like the daily price also starts with 0, right? Oh no, you adapt.
I think that's to say. I think that's to say that they want to create an integer or like a floating variable. That's why they put it that way and not none. I think they will specify, because I think when you have like number variables, you need to specify exactly if they are integer, if they are floats, something like that. Yeah, basically. But when you just update as a string variable, it just becomes a string variable all along.
Okay. Okay, yeah, but like none of these are string variables. Like none of them. So time step goes like from 0 until whatever. The daily price, it changes with exchange, and then if per BTC changes, also changes. But yeah, I don't know if why is this run, by the way? I wonder why is this run. If I didn't run it, it doesn't matter. I'll run it again.
I mean, we can always check with the developers if.
I didn't understand your question. I'm sorry.
So you have like time step, daily price, and ETH per BTC like variables. Okay, those are your initial state. Okay, and
yeah,
I like the difference between having like 0.0 in daily price, and this is a Python question rather than like a question of like the of the hack. It's why is it here none like to daily price if both are numerical outputs. So this one is a sequence like that I know, but this one is not a sequence like this one here.
But the time step is not going to be a numeric variable. It's going to be a string. It's going to be a date.
Yeah, but
that's why it's set to none.
But this one is not a string.
How much it has changed since last day?
Yeah, yeah, I'm not sure. Actually,
I think that has this. I think if you scroll below, we will probably find out why.
Okay.
Let me see exchange.
Because
it's going to be a list. Mm.
So we can check it out if you want later, but I just like to keep it in mind. Just run this one.
I can write that question.
Yeah, I think we can always ask the guys behind it, just to be sure.
Exchange per times.
It's number 7, right?
It's number 7, yeah. Like, it's probably a very silly answer. Like, and I think like more or less I tried to listen to the video, and the video they kind of mention it a little bit on the surface, but I didn't fully grasp it why. So basically here, the only policy function that there is the price exchange. So it basically checks in every substep what is the price exchange, and depending on the price exchange, that is going to change the state update functions. Okay. So
yep.
The price exchange is basically returning a timestamp with a daily price and like a concrete daily price. The daily price, if I'm not wrong, the daily price should be a list in which you have like the price of BTC and the price of like and or from ETH, I guess, right? Okay, then you get the state functions. I know this is the state. The state functions, which are timestamp, of course. This is again what we saw last time. It doesn't give us any extra value.
It does. I actually ran one without the state variable timestamp, and actually what it does is that on the first timestamp, for some reason it retrieves no valuable. It doesn't query the data, basically, because the timestamp that you have is not the one that you requested, it's the one that you created. So if you just run the number of timestamps you put it in the Sims config instead of the timestamp that you created, you're not going to get the data from the first timestamp.
So whenever you want something to change over time, you will have to define as like a state parameter of like timestamp or what?
No, it's just that when you're requesting, when you're making a query request to the API, basically you're going to be requesting, for example, a year. Timestamp one timestamp equals 1 day. For example, if you just use the timestamp that you use in the Sims config, you're not going to be getting the data from the first from that first timestamp.
Okay. I get it. So you're just...
I can share the screen after once you get it, but I don't understand why either. I just tried it once.
Okay. So hey, Christian, how are you?
Yeah, good day, guys. What's up?
So
What's up?
are you able to follow?
Fine.
Are you how is it going? Like or
You mean follow up on the CADcad?
yeah, like did you do the hacks, or are you just like here to just like share if you can get stuff, or like
Okay. No. Okay. No. I just got into a new job, so I'm trying to adjust to it. So I've not scaled through it CADcad now.
Okay, so basically we are recording this session, so we don't get like caught up. We are gonna continue with our CADcad stuff, and then afterwards we can always discuss stuff and like next steps if you want.
yeah,
If that's
100%.
okay with you
All right.
guys.
So sure. Thanks a lot.
Yeah. All right. So I don't know if I
Okay.
run this. Like I will run this.
Okay, so this is pretty much the standard stuff.
Yeah.
Yeah, state update functions, they take the stuff from the policy inputs and okay.
Yeah, is really and the only one that has a little bit of like of something is the daily change, because it compares the total value with the past value. Is the only one that has like a certain type of equation there. Still
Yeah.
pretty easy. Like nothing.
Yeah, pretty trivial.
You can
But
see it like the state update functions is nothing to consider here. One time you run the simulator.
yeah, that's pretty
You know
much
what?
it.
Yeah.
I have a doubt actually. I have a
Okay.
doubt.
Yeah.
Let's say you ran 2 simulations
Yeah.
of Monte Carlo. Where is a random seed being applied within this experiment, like on the state variable function or the policy functions? Because I didn't notice them. I think you're gonna get the same because you don't have like any random application to the system.
Exactly. I think you don't have any C actually, because there's nothing to actually like we didn't provide any how do you call it, variability.
Yeah.
So any randomness.
Exactly. You don't have any random like a variable here, so you're gonna have like the same results, right?
Yeah, so
So-
this is not a Monte Carlo run technically, it's just another run with the same stuff.
Yeah.
My
it-
understanding.
So yeah. Okay, that's what I wanted to reach, because I found it was, yeah, exactly. Because if you ran infinite Monte Carlo runs, they're all going to be on top of each other. They're going to be the same, basically. So it's kind of useless. It's just going to drain computational power from your computer in time, basically.
I assume you don't have any random parameters, so it doesn't have anything like to you're actually, in this case, you're actually getting the data from like an API. So no matter how many runs you do, you can't get like different results, like, or at least you shouldn't, right?
Yeah, this exercise, I think it's just a way to output the data in a visualizing form. Basically, that's it. You're not doing any simulation, it's just the data itself, I guess.
So is this line normally there? I didn't get this line.
It just sets up in the pandas like library. It says, okay, when you call the dot plot, it's gonna use plotly syntax. You can use like different stuff for that, but in this case they use plotly. So basically, if you look at the documentation, you can define in the pd.options.plotting, that backend, you can define different stuff.
Okay.
So that's why they use it. I don't know if they used it before, but I think they did in the previous hacks.
Okay. So in order to put here dot plot, you need to run this before. Okay, because I would not have made any relationship between this. Okay, good.
Because it uses then the syntax for the plotly stuff. And,
all right.
That's my understanding.
Okay, cool. Thank you. What happened here? Okay, all right. So we get like, as you can see, you get overtime. which I don't understand why you get only like 3 months. Because we only run like hundreds substeps, I think. If you do here like 1,000,
Yeah.
like you can do more. So
it's the first 100 days, basically.
Yeah. And you have like the same here. So basically, this one is interesting, like because you're getting the information like from a proper API like that has like a data sets, and you can actually here define the range that you want to have, which I think is pretty nice. So you can
Interesting.
I think
This can be used for data analysis.
Yeah,
for
100%.
Like if you wanna analyze like the movements and stuff like that. But
Yeah. Okay.
interesting.
All right then.
Actually, I just had an idea. Let's say that, for example, instead of the last date being 1 of January 2021, you want to do the current time step, like constantly updating on the moment. How would you do that? Is there like a key?
That I haven't found. That I haven't like checked. Like that was not covered.
Okay.
But
Okay.
we can try at least. Like we can check if it's updated. You know, we can put here.
Put today's date. Yeah.
Or maybe use indexing or stuff like that. You can always use the like -1 thing.
One sec. I don't know
Probably, maybe.
which one is the month and which one is the day, because I know that like the Americans fucking
The month is the first. It's the first. Put 2022 instead of 2020.
Okay, so here it doesn't matter. Here I can put like 21 and here 22. But like if I want to see if it's
No.
What?
No. I'm just gonna put 22 on 2021, and then on the second one, which is the children one, just put the current date. See, it's constantly updating.
Okay. But the current date, I want to hear. This is the month. I assume, right?
Yeah.
And today, exactly. I'm gonna put yesterday, right? Or are we gonna put like
19?
No. Okay. Today. All right. Let's try to run it again then.
No. But now you need to change the time steps because it's not 100 days. It's like 200 and something.
Yeah.
Just put 300 days.
Yeah. Where was that?
It's probably going to. It's probably going to output 300 days.
Yeah,
and it's probably going to put It's going to output an error because we don't have 300 days yet. But let's see what's going to happen.
So it did. Oh, let's see if it ran. It did run actually. It did get like a price per BTC.
So nice.
Pretty good. So it's updated. And why didn't it run at all? Where is it?
Only
it didn't run. I think. Did it run?
It loaded the stuff from the API, but it didn't run the simulation. You can see the error in the CADcad.
Let me check. Just well all above.
It will crash on the here.
It crashed here. Why?
Yeah. So I think it's just maybe we have more range, more days than actual. We have more.
That's what I was going to say.
So we put here 100. So
it's 100. That's okay. Yeah.
Yeah. Let's try to run here all above.
Yeah, you need to run the stuff. Yeah, that one too, and the next one.
Yeah, and then this one works.
Yeah. All right. It's all right.
All right, good.
Yeah, it's gonna work.
Nice. Okay, and then let's see.
Yeah, but what I was trying to do was. Yeah. All right.
Pretty good.
What I was trying to do was to find a way to basically get the current dates always, basically.
I think you can do it. I'm not sure. I need to look into it, but you can do it like maybe by indexing. You know, like putting the how do you call it in the fetching part of the data. You can always maybe use the index and just always fetch the latest date, like -1.
But I think it's not a list. It's a dictionary with the dates, right? The dictionary where the key is the date and the value is the value is essentially the value. It's the price change, I think, isn't it?
Yeah,
probably. Yeah, I don't know. Probably, I don't know.
I think that's something that you can actually ask in the CADcad group. That's something that is actually like, hey, when you like, like I think this is pretty nice question to have. Like, you know, it's something that people would be willing to answer.
Yeah, and I think it would be maybe valuable for us, like, you know, in the long run, you never know.
Yeah.
So maybe, I don't know if you, Tiago, are taking notes and or stuff like that. Maybe
I am.
you can.
I am.
Great. So,
I am.
Great.
So we can.
Thank you.
7. Okay.
All right.
How to request the current dates. Okay. Go on.
Then this was then we go to number 8. Number 8 is sensitivity analysis. Actually, this is pretty useful. I've seen a couple of videos in which they use it. So it will be like, it's not very complicated, and it's basically, okay, we go to the video, like they tell you a little bit the use cases here, how to perform, because it improves your decision making. It allows you to observe like where's the like what are the parameters that are important for your results and things like that, like what is relevant in your results. So they do it by, in the first case, they want to just do like sweep parameters, which is something that we already did in the bootcamp. And they want to do it in a fancy way, which is by design it like by a Cartesian product. I don't know if you know what a Cartesian product is explained here, but it's basically you take 2 lists and you try to get all the possible combination that you can get with that list, you know. So the parameters. So if you have 1 2 1 2, you have 1 1 1 2 2 1 and 2 2. Okay, so that is basically what they do here. Nothing more than that. They added here the iter tools, which if I am not wrong, the iter tools is basically in order to allow for the Cartesian products to occur, right? Yeah, exactly. So the iter tools is basically a library for being able to repeat like sequences in a list.
Yeah.
All right. Then here I am a little bit confused. I did get a little bit confused because I think they define the parameters to sweep, which I think it's the same thing as here, like that here above. So basically here they define the Cartesian product, and here they apply it. But but I don't know what this means. What means like two stars?
It means all the parameter sweeps, all the objects that the variable carries, basically.
Okay, so you get here the prey death, the DT, and the prey death parameter.
Yeah. Do you understand what the line space means, by the way? Okay, so it's written in there.
Okay.
Basically creates. Yeah. So basically creates like numbers that are separately distanced. For example, the first number is the initial number, the second number is the final number, and the third number is the amount of number that you want that are within that interval, and they are equally spaced. So for example, the list that would, I think that returns a list, I think. But like the list that would return would be like 0.2, and that would be 0.7, and then 1.2. Yeah, I think that's it.
Okay, basically. Okay, all right, and but it's but it takes this number and this number as like the beginning and end, or does it take like random numbers in between?
No, they are equally spaced numbers.
Okay, so it takes, for example, here, because it's 3, it would take like an extra number in between that is equally distanced to 0.2 and to 1.2.
Yeah. Okay. Like imagine you had like the first number would be 1 and the second number would be 10.
Yeah.
And then the third number would be 1. That means that you would have 10 numbers that are equally spaced between 1 and 10. And so you will have a list that contains every number from 1 to 10, basically. 1, 2, 3, 4, 5, 6, go on.
All right. Yeah, good. Yeah, that I get. Okay. Then in that way you get But you get these three. Like
I've
why?
not looked at this Jupyter notebook since 2020, 2019.
Sorry.
Sorry?
You use it for.
So one sec. I'm gonna stop there. All right. Continues. Like all right. So we have. What I don't understand is the parents to sweep. So we have like 3 parameters to sweep, but then we have like the parents, which is okay. So there is this extra one. Okay.
Yeah, I
Now I
think
get it.
that's going to output the list of all the parameters combination.
Exactly. So this one gets all the combination from all these 3, and then on the parents you need to add these extra ones that are fixed, which are the predator, birth parameter, predator. So because you're only creating the Cartesian product, like for this ones. For this ones you're making it fixed.
Yeah, but I actually have a question because I don't really understand how different that is from just creating like the parameters within the params dictionary. Like that would automatically do as well. Why do they do a Cartesian product?
Because imagine you have like because you want to be able to change all of this. Imagine you want to create here like 6 or like 7 ones or different ones, you know. It would be very annoying to have them and to have them all in the same like you're gonna make like a special function for it. Like if you think about it, they say the params and they define the fixed ones, and then they put the variable ones like here that they have defined before, because they want to make it a little bit more organized. Actually, I think it's pretty well done like this way. I don't know if I explained it well, but it's more clear. It makes it step by step possible. You know, here you define how to make the product. Here you make a use case for the product, and here you're using the result of like why you use those like function.
Yeah, but like let me see, params was 0.2, Yeah, but for example, you could. Why, for example, if you use just the params that you have on the params dictionary, for example, that's like one random one, the birth parameter, which has 1.0. You added another object like 2.0. The simulation.
That simulation, sorry.
On those parameters, because that will also result in a parameter sweep. You know, why don't just do the parameter sweep within the params dictionary? I'm still confused about that actually.
Here, because here you have not defined the parameter sweep. If you think about it, here you have like only defined like the NP line space, but if you want to change this number, the parameter sweep is going to change. So if you add here 2.0 or like 3.0 or something like that, or whatever, and you're gonna get like fixed results, and you want to have like a more function over it. You're gonna be able to play more with it. At least that's what I understand. I don't know if I'm answering your question. So if you
scroll down, please. I'm sorry. Could you scroll down?
Yeah.
A bit more.
Yeah.
I want to see the output. Wait.
I don't know if this is the output, but yeah, I guess.
Yeah, it is. Yeah, trying to. Yeah, I'm a bit confused. I don't know if I'm explaining clearly. It's just that on the foundations course, they did a parameter sweep with just like adding more than one object within the lists in the parameters, and the parameter sweep resulted automatically. You could already defer the different simulations from the CADcad that run automatically, basically.
Yeah, I think
I'm just curious why did it.
I think if you add here another one, if you add here another one, you can do that.
Yeah, it's going to be another combination, right? So
yeah, it's going to add it's going to add another combination with all the ones that you had before. Yeah, I think so too. It's just I think here is like the Cartesian product is now I know what you mean. Why do you need this extra one, right?
Yeah, exactly.
If you're already doing this one.
Yeah, exactly. That's my doubt. Could you scroll up again, please? I think that's because of the machine learning package they're going to use. I don't know, but I don't understand. I still understand because it's also going to be a list. I don't understand why. Yeah,
Oh.
with the param values, computing values.
Maybe here you're
Yeah,
generating the list, and here you're not like generating the list yet. Like maybe here you're just defining the values, and like you need to define the list, and then you do it by this, like by creating the product. I don't know.
I think that returns a list.
Yeah,
That returns a list also.
Yeah, it's like it sounds reiterative. Yeah, it sounds like a little bit repetitive, like the fact that they need to do it.
I don't know. I'm gonna ask them. I'm really confused about that one.
Okay, all right. I don't know if I run everything.
Right, number 8.
Number 8. The rest is everything very similar. Nothing has changed here. Everything here is actually always the same. I think they go directly to. What was the point of this one? Sensitivity analysis. Oh, what happened here?
Run different.
Yeah, I don't know. Maybe it's. Do you think it has to do with the CADcad?
Yeah, but like it still outputs. It still outputs the list. That's the thing. That's why I'm confused.
Okay.
I'm gonna ask the developers.
Okay, here it works. Parallelized. Took 3 seconds.
Yeah, not sure. Just run it again. It's gonna work.
Yeah, it did work. What we got here? Here nothing changed. We have the same here again.
And I also have some doubts on the decision tree. Also, I didn't quite understand the true and false stuff.
Me too. I also have the decision tree. Okay, we have here the parameter sweep, which we already have seen before. It's actually nothing new. You got like the time step here. You got like the 2 variables here that are like two how do you say, the return variables that are like the tt, and you get here the different parameter sweep.
Oh,
like
by the way.
Yeah.
Just knowing the concept on the DT is just the time, like the rearrange of the interval. Basically, you basically want that one time step is equal to 1 divided by 0.2. Basically.
So basically, one is short term and one is long term, or what?
Basically, yeah, exactly.
All right. We have an auto scale here that I don't know if it worked, and then you get the visualizations that.
Yeah, that
didn't visualize. Here, no, this is one. And then you get here, which is pretty annoying, because so I've done in statistic like decision trees before, and normally it takes what it does is it takes decisions based on an objective that you want to get, so you make like you make a assumption, like an assumption that of like an objective that you want to get. In this case is like the key performance indicator is that the pre-population is 5 times above the predator populator at least 19% of the time, and checks like when will that happen, where are the situations in which that happens. What I don't understand is like how do they decide it, especially because they say that left is true and right is false. Okay.
Yeah, exactly.
And you get here left not true, right threshold met, like left like threshold not met, right threshold. So I didn't get this exactly, like how it developed, and also how it goes from threshold met to later again not met. So I do get also a little bit confused about the tree, but at least you can check more or less that basically here you are indicated a little bit like the prey depth parameter seems like quite relevant. The DT with this like with this numbers is also like relatively relevant, and this one I actually don't understand very much.
Gini is basically a concentration parameter. It tells you, like, for example, how much the population is concentrated with a certain percentage of the population. For example, You can apply a Gini concentration parameter. For example, how much wealth does the whole population have?
Exactly.
If you have a high,
yeah.
Okay, but yeah,
It's a
basically,
decentralization.
if you have a high, yeah, exactly. It's how much inequality exists within concentration. Basically.
Exactly. Yeah.
The
But
higher it gets, the bigger it is.
what I don't get here, because here you're establishing like parameters that you have, and you're getting it like here updated, but like here you only get like the Gini, which is not relevant. Samples, it explains you what percentage of a sample, but I don't understand what the value 0.0 and 1.0 means. But because here it says it's true. Okay, so we got here 100% of the sample. So 66% of the sample, it doesn't meet our KPI. Then you only have like 33% that does like complete it. But from that 33%, 11 of it does not. Okay. Now I get it. So when the predator death parameter is below or equal 0.95, so when that is true, the threshold is not met. When that is false, the threshold is met on a general basis. Okay, but from this 33%, you can even separate a little bit more. You can go to 11% that is not met when the prey death parameter is below 0.015. Okay, so you take out another 11% that has like this statement as true. So when you have this statement false and this statement false, you have like a third statement, which is the DT below 0.06. When that happens, it seems that like you have like 11% that is like fully right. On the other, on the right, you get the white one, which is a little bit indecisive between the threshold is met or is not met. But here it says it's not met. But when the prey death parameter is below 0.045, so from this 11% that is extra from DT being above 0.06, that part is divided, but in general the threshold is not met. But then they make another statement in which the prey death parameter is below 0.045, and that percentage, that 5.6 percentage, is met. So in total, you would have like 5.6 and 11.1 of threshold met, more or less here, as a 15%. And here you would have like a 33%. So this is like a kind of like a better way to get to a more detailed cluster. Did you understand? I was a little bit confusing when I explained it.
So the sample percentage means the proportion of the sample which it is true. It verifies the true statement.
Exactly. So you have like here a 33%, okay? And if you take the whole 33%, like you need to say a yes or no, it says yes, because the threshold is met. But from that 33%, not everything is not everything like reaches the threshold. So you want to go a little bit deeper on that. So you check another parameter. So you realize that in reality you have like a 16.7, which is above the half of 33.3, which is right above, like not much. That like if you check this parameter and like so the prey death parameter plus the predator death parameter plus the DT parameter plus the prey death parameter, you can get to a way deeper cluster. So you make less mistakes, because if you stay here, you will have all the errors of, for example, getting all the prey death parameter that are below 0.015 that like do not meet the threshold at all, but they will still belong to this group. Do you understand?
Yeah, I'm glad. Yeah. but I think I'm gonna need some further explanation.
Okay.
I'm still a bit confused about it.
Yeah, it's a decision tree. So you want to get
So
a deeper cluster, because it really depends on you and you need. I don't know how to make this smaller again.
but that's like to output how important a certain parameter is for that certain result.
No, that's here. That's
for
below.
for the.
So this is the importance.
Okay, it's importance. Yeah, it's importance. Yeah, that's what I. Okay.
But in the
That's what I was going to say.
in the decision tree, there is also a range of importance. So it takes first the most important parameter and it divides it in two. Okay. And it assumes that the most important parameter to determine whether the threshold is like the KPI that we defined is true or not is defined by the predator depth parameter. Okay. All right.
Yes.
I
got that. Yeah.
One that decision is done, you have a percentage on one side or a percentage on another side, and you go to the same parameter or a different parameter, and you define it again, and you make it again at level of importance. And in this case, when you already took out the predator depth parameter below like 0.95, you assume that the most important parameter is the prey depth parameter. And you iterate, that result until you get to a point in which it doesn't make any sense to make a division of importance anymore. That is more or less the conclusion. Normally you establish like an end. I don't know if it's here the 0.9 exactly. I don't fully know.
The function, the weight.
5.0. I don't know, but normally you establish, because you can continue the decision tree forever. Like if you want to continue like a percentage, because you have like here a 5.6, and unless like the 100% of the 5% is like that, like you could continue and keep separating, or maybe here, like while the Gini is like 0.46, maybe you can still separate it. But yeah. The important part here, I think the future importance is pretty relevant, and I don't know why I cannot make this smaller. I'm sorry. I'm going to run it again and see. Why do I have this now wrong?
Run the above again.
Yeah.
Try to run the cell now.
Okay.
Yeah, but
I made a mistake.
Oh, you're gonna have to pip install it. Forget about it.
Okay.
You have to install that shit basically.
But because it didn't run. Okay, it's fine. Yeah. So the important part there, we can watch it in the video. It's basically here is established that the most important parameter by half, like taking half of the importance, is basically the predator depth parameter. So if you would take out the predator depth parameter of your model, you would miss out a lot of like important information. Whereas if you would take the DT information, which one is it? I think it's the DT, right? If you would take that information out, your model would still be quite robust, because like at least more or less 80% of the information would still be there. So like this one only adds 20% of the information, whereas like this one is more like it's 50%.
Yeah, so basically that's the importance of how much each parameter influences the output results.
Somehow, exactly. Okay. For the KPI that you have like established, for this one specifically.
Okay, for that KPI. Okay.
Yeah.
Okay. Above 90%. Okay.
Yeah, because maybe for something else, like because here you were checking about like when is the prey population like 5 times higher. And it makes sense. That depends on like how many like predators die, because if the predators do not die, then the prey population cannot grow well enough, So they established that like, it's more important that the predator depth parameter than the prey depth parameter. So that's more or less.
Okay, I've got a bit of a grasp on your explanation. Thank you, but I still think that I need a lot of further explanation. Yeah. So I'm gonna try to investigate on myself.
This is just check random forest and decision trees on statistic. Like those. That's I think that's what they do here. Yeah, exactly. Plot the decision trees and random forest. Like those are the two things. And
It's funny because I'm gonna be learning that when I start my master's degree.
yeah.
Really, I'm gonna make a master's degree on computational statistics
Probably
as well.
probably
So,
with R or MATLAB, something like that.
Python and R. Yeah, exactly.
Yeah, okay, yeah. No,
Python and R.
I used to use R. All right, I think that's it for this one. These two are more or less like useful for certain occasions. We can go to the 9 one. This one actually got me because I don't know how to use it. Maybe you guys can help me. But okay, this is not what I wanted. So if I do Control L, so okay, perfect. So 9.1 is how to export the notebooks. So it's actually very simple. It basically tells you that we have this. Where is it? There is.
Oh, it's more like how do you call it, Jupyter stuff, right?
Yeah, exactly. It's a little bit of. It's about like how to export on Jupyter in the files that you want. So you have like these files that you want to export. Okay, you want to export it in PDF through, like, you want to export it like on LaTeX on PDF, and to web PDF is also possible, to HTML or to .js, I guess.
Reveal.js. It's like for presentations and stuff like that.
And Markdown, I don't know it. I don't know Markdown.
It's how do you call it? The readmes are written in that. It's probably gonna be converted into .md file.
.md,
file.
exactly, .md. And what I don't know how to do is this part. To be honest.
Just to call out.
Yeah.
I'm just gonna say that's how it's called. It's a shell file. Basically, it's a command prompt file that if you run, it's going to run on your computer interface, on your command line, basically.
In the video, though, they say that you should run in Windows, you should run every line individually, because when you run the whole document, it doesn't work that well. That's what they say.
Yeah. Exactly.
What I don't know is how to run it. So I went to the. Oh no, I don't know what happened here.
It's Bash language that they use, Git Bash.
Okay, I am not I'm not very good at the language, or like I don't know the language specifically.
No,
so
forget about that shit.
Okay, okay. I didn't find that relevant unless, like, in the future someone will help me with this if I need help. Like that's so it's not very relevant, but it's basically using this. These are the 5 possibilities that they give you. That's
it's very useful indeed, but don't get into that too much. The one in which you just really need it, basically. Yeah. It's not going to affect your work today basis.
Yeah,
basically.
So we go to the last one, which is the generating stochastic processes. This one, I think, is pretty impressive, to be honest, because I still need to grasp like how they they do it. So basically, they get an API. They get like the same API as before. So we're like tackling like from CoinGecko. We want to like take the change in Ethereum, like the comparison between the price of Ethereum and the price of Bitcoin over time. Okay, which I think is like again the same thing. They don't change a single thing. So everything here is completely the same.
It's the same, right?
So I think it only changes in the last section
they import statistics libraries to do the gamma and normal distributions.
Exactly.
To predict future prices, basically.
Yeah, and this is what I get confused. Okay, so we get here. Okay, and then they want to get like a gamma distribution generator, and so how the fuck do they define the range? Like, so I don't understand how do they create the
distribution.
The distribution. Like, is it based on this data already, or how the fuck do they so
I guess they assumed that the price changes would have a similar distribution as a gamma one. And basically what that function says, it is the parameter that they take in order to do that distribution, basically.
okay,
And
which parameter do
okay,
they
wait a
use?
second. There, the return ST gamma RVS.
Return.
Because gamma takes okay, it's not parameters from parameters on the system parameters. It's parameters for the function itself, for the gamma distribution.
Yeah, so I understand that they take, but like, how do they generate random points that are that close to the data frame results? That's the part that like fucks me up. Like, how do you get this? Like, I don't understand. You have like some random data, so you have like the real data, which is the blue one, okay?
Yeah.
How do you generate like gamma data that applies that well? Like, why is it not completely random? Why is it instead of 0.015, it's not like a 0. Like or like 3.1, or like how does it? Like,
Well, I think that's a characteristic from the distribution itself. I think they assume that the price changes have that kind of distribution, so it is very similar, like, basically.
But do they? Like,
I don't.
My question is, do they use as I don't know, maybe average or like standard deviation or certain parameters of the real data in order to I think so,
Okay.
right? In order to generate that data, because I assume that this is new data that I can accept, but is that new data based on some data that has like already been there? So if we had like different data, for example, if we would I don't know, like again, like the other, like before, change the date that we put here, we would have like a different distribution of the price, like change, right?
Okay, I got you. I'm getting.
Would that influence the data that you generate? And that is my question. If it's yes, then it's great, because that means that you're taking a variable of the real data and you're just like making a full distribution, gamma distribution based on that, and that I accept. But like, if it's just like out of nowhere, just because like the distribution generates random data, I don't understand how it's done.
So it is based on the data, because it takes the argument as the data frame, and then it just outputs. So wait a second, generate to. Could you scroll down?
Yeah.
More. Onto the next cell.
So to this plot.
Yeah, I get you now. Yeah, I'm getting you. Yeah. Now I have listened out as you have. Yeah.
So I think in this, I do think that there might, like, in this process of like generating data, they are like referring at certain points to this data.
Probably.
They must do, like, otherwise I do not know how they fucking know that.
Yeah, probably.
Because otherwise the data would be completely random, and that is the part that I find it a little bit confusing. I don't get, because in the video they say that the data is completely random, but I do not accept how.
We can always ask this.
Do you know? Do you know what's weird?
Yeah.
Is that when he calls the function, he doesn't even put the parameter. If you notice, on .pipe generate gamma function, it's like it's if the arguments are with the default arguments. Do you get what I'm saying?
So
On the fig diff, fig df, fig the frame, on the pipe, he calls the function, but he doesn't provide a parameter. He doesn't provide a data frame.
Yeah, it's actually it's weird.
Yeah, I don't know. I had the same with the other, like, I have the same question with the normal distribution.
But you know, that's a function that comes from the statistics library that they imported. So it probably has properties that we don't know yet because we didn't cover.
Yeah.
So
they
it's something that I can investigate as well.
they need to call out, like, otherwise their range already of like what do they find the range of like where their random distribution is done. They need to. I don't know if it's these numbers. I don't know like where does it like, but the generation needs to come from somewhere. Like they cannot make it out of thin air. Like and it's just like how many normal distributions are in the world like that have like different like an average and a standard deviation and things like that, and this one looks extremely similar again.
Yeah.
You know.
Yeah, I'm getting you.
Like that's the part that like I get confused.
Yeah.
Yeah, and actually funny. Here it should be both are long-tailed. Weird. Yeah, strange.
We'll see.
Yeah. So those were my doubts. The rest is actually only applying the fucking the new way of like the new functions that we have here. So it's just like an add-on, like in same of like visualization. So it's a nice way to kind of, if you have like a sample with little data, to generate more data based on the data that you have. Like that's what the conclusion that I get. So that like you can kind of like inflate a little bit your database so that you can actually work better with it in certain occasions.
Yeah, agree.
Yeah. And that would be it. I think we've been an hour.
Nice.
Yeah.
I think we did it in like an hour, like sharp.
Yeah, it's good.
Okay, I have 5 questions. I'm going to try to get the answer to by tomorrow.
Perfect. Thank you.
I'm going to watch a movie in a few minutes.